Section 4.3 is right triangle geometry. So we can take the following trig functions, and when we were talking about them in terms of, we looked at measuring them on terms of the unit circle, but when we're talking about triangles, the following formulas and relationships we're defining here only apply to right triangles. So there's an kind of an anagram that you guys heard back when you were growing up. A lot of you heard SOHCAHTOA. So that kind of helps, a mnemonic device to help remember this. And we spell it like this. So the S stands for sine, and then we have a little OH, it's opposite over hypotenuse. The big C stands for cosine, adjacent over hypotenuse. And the capital T stands for tangent, and it's opposite over adjacent. So in this triangle I've drawn here, I've got theta, right? This is the side adjacent to theta. This is the side opposite of theta. And the hypotenuse is the same as it ever was. It's always the side, right, the longest side of the triangle, but for a right triangle, it's the side opposite of the right triangle. So depending on where you place theta, that can flip the relationship of the opposite and adjacent. So for example, if I define this angle as alpha, well, this is now the side opposite to alpha, and this is the side adjacent to alpha. So sometimes you'll be given problems where you have triangles with two different angles labeled with different Greek letters, and you need to know when you're doing sine and cosine, are you counting for the sides properly? So then after we see cosine, sine, and tangent, right, these are just the reciprocals of those, and so we see the ratio flips upside down. So let's look at problem 7. It says assume theta lies in quadrant 3. Oops. And the terminal side of theta is perpendicular to the line y equals negative x plus 2. Determine sine of theta and secant of theta. So the first thing that I was told was that theta lies in quadrant 3. So I'm going to draw my x-axis, and the terminal side of my angle is somewhere inside this quadrant. And I'm going to let this form a right triangle with the x-axis. Then I was told that this line right here is perpendicular to this line. So the slope of the line I was given is -1. But a perpendicular line, it's the negative reciprocal. So it's -1 divided by 1, which is +1. So why does the slope matter? Well, the slope, 1, is the same thing as 1 over 1. The slope is still defined as the change in y over the change in x. So that means that I have a negative rise, right, over a negative run. So in this quadrant here, this is in the negative x direction, and the negative y direction, this is -1 times -1. So I have to go down and over 1. This is the slope. So now I know 2 of the sides of my triangle. So whenever we define the terminal side in terms of the slope of the line, this is what you do. Delta y, delta x, but you want to make sure you put the appropriate signs based on what quadrant you're in. So now I need to find the hypotenuse. So I'm going to call that r. And I can just simply use the Pythagorean theorem to get r. So -1 squared plus -1 squared equals r squared. 1 plus 1 is r squared. So 2 equals r squared. So the square root of 2 equals r. The hypotenuse is always a positive value. Only the x and y coordinates get signed values, S-I-G-N, not S-I-N-E. So now that I've got all 3 sides to my triangle, our angle theta is here, and now I can calculate sine and secant. So sine is opposite over hypotenuse, so that's -1 over the square root of 2. Secant is 1 over cosine, so if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So that is the square root of 2 divided by -1, or negative square root of 2.